Good morning, students. Last class, that is in previous class, I have finished the problems on roster form and set builder form. That is how to convert roster form into set builder form and how to convert set builder form into roster form. Like that, different types of questions I have finished on roster form and set builder form. Today also we are going to solving different types of problems on null sets, finite sets, infinite sets and equal sets. That is those types of problems are belonging to the exercise 1.2 here. That's why let us now we are going to starting the problems from exercise 1.2. That is 1.2 questions now. First question. Which of the following are which of the following are which of the following are the examples of null sets? Null set. First question. Set of odd natural numbers. Set of odd natural numbers. Odd natural numbers divisible by 2. Divisible by 2 cube. See here, no odd number is divisible by 2. If you can take any odd number, are you seeing here odd numbers are divisible by 2 here? 3, 1, 3, 5, 7, 9. Like all these odd numbers, they are not divisible by 2. When they are not divisible by 2 means we are not getting any elements. That's why the given set is the null sets. See here, answer for this question is no odd number is divisible by 2. No odd number is divisible by 2. Divisible by 2. Therefore, the given set is null set. The given set is null set. This is the answer for this question. Second question. Under the main number only, they are giving some 4 sub-questions. Number one is set of even prime numbers. Set of even prime numbers. Set of even prime numbers. See if you can see that one of the prime number is even. If you can set of all prime numbers, set of all prime numbers, among all those you are saying one is even, that is 2. See at rough side if you can set the prime numbers here 2, 3, 5, 7, 11, up to and so on like this. Among all those 2 will come. Here 2 is called even prime, even number at the same time prime number. That's what here we are calling 2 is even prime. That's what we can write. The given set is not null sets. The given set, answer for this question is the given set is not a null set. is not a null set. Null set means empty set. It's not a null set because set of elements 2 will come here. 2 will come. If there is no any element in that within this floor bracket, then we are calling those sets or null sets. But one element you are getting no singleton sets. Only one element present in this set means we are calling that set is the singleton set. That's why the given set is not a null set. Now let us we are going to moving to solve some more questions now. Next question. X says that X is a natural number. Third question. X says that X is a natural number. Is a natural number. Natural number. X is less than 5 and X is greater than 7. Less than 5 and greater than 7. Both should be. That number should be less than 5 and greater than 7. No numbers you are getting. Less than 5 you can take numbers 1, 2, 3, 4. Less than 5 only. But they are not greater than 7. Or greater than 7 numbers you can take now 8, 9, 10. 8, 9, 10, 11. Like that if you can take numbers. They are all satisfying one condition greater than 7. But they are not satisfying the condition less than 5. A number, if you can select a number, means that must be satisfied by these two conditions, less than 5 and greater than 7. But no number satisfying these two conditions. No number satisfying these two conditions, less than 5 and greater than 7. That's why the given set is the null set. The answer for this question is the given set is the null set. The given set is a null set because no number satisfying given two conditions less than 5 and greater than 7. Next, fourth question. Fourth question is y is such that y is such that y is a point common. Y is a point. The point common to any two parallel lines. To any two parallel lines. Any two parallel lines. See, whenever two parallel lines means we are not seeing any common points. If they can intersect, then only we can mention a point is common of those lines. So diagrammatically I am showing here, if the two lines intersect, then it is a common point. If parallel means we can't say here it is a common two parallel element L2. That's why the given set is the null set. When the lines are parallel means we are not getting a common point of those lines. When those two lines must and should intersect at one point P, then we can tell that P is a common to those two lines here. That's why the given set is what we can write about this given set, your null sets. The given set is a null sets. Answer for this question is the given sets. The given set is a null set. Is a null set because no point is common. No point is common. Is common to two parallel lines. The null sets. Like that we have given examples on which is null set and which is not forming null set. Like that we have finished the first main question of exercise 1.2. Now let us we are going to moving to solve second main question. Second question is, which of the following are finite or infinite sets? Second main question, which of the following are finite or infinite? Finite or infinite? Infinite. Finite or infinite? First question is that. The set of months of a year. The set of months of a year. Here in this main second question they are asking which is finite and which is infinite. When I told finite and infinite sets, in case of these two I have given definitions also. In case of finite set, the set which is containing countable number of elements, then we are calling those types of sets are finite sets. In case of infinite sets, which type of sets having a uncountable number of elements, then we are calling those sets are infinite sets. Now according to those definitions, if you can apply the first definition for the first question, the first question having the set of months of a year. In a year, how many months? There are 12 months. That's what easily we can count them also. That's why the given set is the finite set. Why? Because the statement having a countable number of elements and the set having a countable number of elements. That's why the given set is the finite set. That's why answer for this question is that the given set is a finite set. The given set is a finite set. Is a finite set because the set contains countable number of elements. Countable number of elements. Countable number of elements. Countable number of elements means one element is 1 month. Like that we have 12 months. January, February, March, April, May, June, July, August, September, October, November, December. Like that 12 months are there. easily we can count them also. 12 months are there. That's why the set having a countable number of elements, the given set is a finite set. This is the answer for the first question. Now second question. Second question is 1, 2, 3 up to and so on. 1, 2, 3, up to and so on, like this. Here they did not give any limitations. Limitation means this much number of elements are present. Like that they must have mentioned here. But here they did not mention here. From 1 up to onwards, where it is stopping we don't know. That's why the given set is the infinite set. Because we can't count them. We can't count them means the set contains an uncountable number of elements. Answer for this question is the given set is the infinite set. The given set is infinite set. Infinite sets, because the set contains uncountable number of elements. Uncountable number of elements. Uncountable number of elements. Uncountable number of elements. We can't count them. Start from 1, but where it is stopping we don't know. That's why they represented with symbol up to and so on, like this. That's the answer for the second question. Now let us, we are going to moving to solve remaining questions now. Next questions. 1, 2, 3. 1, 2, 3. Third question is 1, 2, 3, up to and so on 99, hundreds. Is a finite set, because they gave the finite number of elements, 100 elements they give. 1, 2, 3, up to and so on 100. That means we can, if we can count them, also you will get 100. Easily we can say this set contains countable number of elements. That's why the given set is a finite set. Answer for this question is the given set is a finite set. The given set is a finite set. Because it contains a countable number of elements. Because it contains a countable number of elements. Countable number of elements. Third question, fourth question. For this, the set of all positive integers, the set of all positive integers, the set of all positive integers greater than hundreds, More than 100, how many parts numbers you can write? 101, 102, 103, 104, up to and so on. That's why, can you count them? We can't count them, those numbers. That's why the given set is the infinite sets. Like this. Solution for this question is, answer for this question is, we can write like this: 100, 101, 102, 103, up to and so on, like this. That's why the given set is a infinite set. The given set is a infinite set. Infinite set, because it contains an uncountable number of elements. You can write same statement here also. Because it contains, you can write also, no problem. Because it contains uncountable number of elements. Uncountable number of elements. Uncountable number of elements. We can't count them. It contains countable number of elements means finite set. If it contains uncountable number of elements, we can't count them. Like that, those types of sets are called infinite sets. So let us, we are going to main question number 3. Same. In main question number 3 also, the questions are belonging finite and infinite questions, because just better some questions are belonging to geometry also here. First question is main question number 3. State with whether each of the following sets states whether each of the following set is finite or infinite. Finite or infinite. Same questions here also. How we solved some sub questions of main question 2. Similar in the same way, we have to go answer to all the sub questions of main question number 3 here. Finite or infinite? In case of finite, the set which contains countable number of elements, we are calling those sets are finite. In case of infinite, which set is containing uncountable number of elements? Uncountable means there is no any chance to count. Those types of sets are called infinite sets. Now let us, we are going to discussing main sub questions of the main question number 3 here. See here, first sub question now. The set of all lines. 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 The set of all lines parallel to x-axis. Parallel to x-axis. See how many lines you can draw parallel to x-axis? Are you giving any finite number of lines? Can you count them? See, diagrammatically I am showing here the y-axis and it is the x-axis. Origin, parallel lines like this. How many lines you can draw like this? Infinite number of lines. Here also you can draw parallel x-axis. Like that you can draw. Like all the lines are parallel x-axis. Like that we can write infinite number of lines which are parallel to x-axis. That's why the given set is the infinite set. Answer for this question is the given set is the infinite set. The given set is infinite set. Infinite sets because it contains uncountable number of elements. Uncountable number of elements. Uncountable number of elements. Here, uncountable number of elements means we can draw infinite number of parallel lines. We can draw infinite number of lines which are parallel to x-axis. There is no any limit. We can draw like this, any number of lines like this. How many number of lines we can draw, we don't know, but they are all parallel to x-axis. That's why in that time the set contains uncountable number of elements. We can't count them. That's what we can write the answer for the question is the given set is an infinite set here. Now let us, we are going to giving answer for second question. Second question is the set of letters in the English alphabet. The set of letters. The set of letters in the English alphabet. English alphabet. It is a finite set, easily we can tell now. In English alphabet there are 26 letters are there. 26 means easily we can count them now. Easily we can count them means the set contains a countable number of elements. That's what the given set is a finite set. Answer for this question is the given set. The given set is a finite set. Finite set because it contains a countable number of elements. Contains a countable number of elements. Countable number of elements. Twenty-six elements are there. Easily we can count them also here. You can count them means it contains a countable number of elements. This is the answer for the second question. Next, the third question. The set of all numbers. The set of numbers. The set of numbers. The set of numbers. The set of numbers which are multiples of 5, which are multiples of 5. Multiples of 5, how many we can write here? So many, 5 comma, 10 comma, 15 comma, and 20 comma, 25 comma, or plus or minus 5 comma, plus or minus 10 comma, and the set of numbers they mentioned, they did not mention their positive or negative. That's what we can write here. Elements of the set are 0 comma, plus or minus 5 comma, plus or minus 10 comma, plus or minus 15, up to and so on like this. That's what answer for this question is. Set elements contain like this: 0 comma, plus or minus 5 comma, plus or minus 10 comma, plus or minus 15 comma, up to and so on. That's what the given set is a infinite set. The given set is a infinite set. The given set is a infinite set. Infinite set. The given set is a infinite set. We can't count them. 0 comma, plus or minus 5 comma, plus or minus 10 comma, plus or minus 15 comma, up to and so on like this. We can't count them. We can't count them means the set contains infinite number of elements. Like that, today we have finished the problems on finite and infinite sets. Finite and infinite sets. It's very simple. In case of finite, it contains countable number of elements. We can call them finite sets. In case of infinite sets, the set which are contains uncountable number of elements, then we can call them as infinite sets. These are the examples for finite and infinite. Next class onwards, we will solve some more problems on finite and infinite. Along with them, we will solve problems on equal sets also. And after completion of equal sets, we are going to solve the problems on subsets and also the problems on intervals also. Like that, we will finish some more problems on next class on this lesson sets. Thank you very much.